Assalamu alaikum. Bismillahir Rahmanir Rahim. In this video, we are going to see how can we find the nth root of a complex number. The complex number might be in Cartesian, polar, or in exponential form. First of all, we start with the square root in Cartesian form, and then we will convert this in polar form and find the square root, maybe cube root and the fourth root, and finally we will check all these answers with the help of calculator as well. That is, we will find the square root, cube roots and the fourth root with the help of calculator. So this video is going to be very informative. The complex number in Cartesian form. Let's take an example. 3 plus 4 iota. This complex number is in Cartesian form. So we want to find its square root. So its square root is going to be a complex number again. So let's see, the complex number is a plus b iota, where a and b are real numbers. A and b are real. So let's start. So we are going to squaring both sides. So 3 plus 4 iota is going to be a square minus b square plus 2ab iota. We are going to compare the real part with real. So 3 equals to a square minus b square, and 4 equals to 2ab. So we get b equals to 2 over a. Substitute this in the first equation. So we get 3 equals to a square minus 4 over a square. So now we are going to solve it, as it is not a quadratic equation, so we have to use some substitution. So first of all, we just simplify it, take the LCM and then do the cross multiplication. So we get 3a square. So let a square equals to m, so m equals to a square. So we get quadratic equation in another letter, another alphabet, m. So m square minus 3m minus 4 equals to 0. Now use the Milton break or you can use a quadratic formula. By using that, we get values of m. So let's do the Milton break. So m, a minus 4 minus 3 minus 4 and minus 1. So it is going to be plus 1. So we get two roots, m equals to 1 and m equals to 4. So let's substitute it back. What is m? M is a square, so a square equals to minus 1. So here a would be imaginary, so as we know a is real, so this is not possible, no solution, or inadmissible you can say. And from here we have a square equals to 4, so a equals to plus and minus 2. So as we have plus and minus 2, so we can find out the corresponding values of b. When a is 2, then b is 1. When a is minus 2, so b is minus 1. So finally, the square root of this complex number, which was 3 plus 4 iota, equals to 2 plus iota, or minus 2 minus iota, or you can write it like this: plus and minus 2 plus iota. So these are the two square roots of a Cartesian complex number, which was 3 plus 4 iota. Now we are going to do the same working by converting this complex number into, you can say, polar form or in exponential form, and then again we are going to find out the square root. But before that, we should know the formula. So let's discuss the formula for the nth root of any complex number. What was that? So if we have a complex number, let's say z equals to r cos of theta iota sine of theta, where r is the length, that is z modulus, and theta is the argument of z is theta. So how can we find the nth root? Nth root of any complex number, that would be the root. Nth root means nth root of the modulus, And for the angle part, you can say angle, or you can say argument, that would be theta plus 2k pi divided by n, where values of k can be from 0, 1 till n minus 1. Okay, there you have to memorize this formula. This is the formula to finding the nth root of any complex number, provided that number is in polar form or in exponential form. Or in simple words, if we have the length of the complex number and its argument, then we can use this formula to find the nth root. Nth root means we can replace n with 2, that would be square root. If we replace n with 3, then it would be cube root, and so forth. So let's substitute n2. If I substitute n2, it means I'm going to find out square root of this complex number. So it means square root of this complex number would be the square root of the modulus thing. And for angle, you will write theta plus 2k pi, and n is going to be 2 because it is now square root, and the values of k which we are going to substitute would be 0 and 1. And if you are looking for the cube root, for instance, then n would be 3, and we will find cube root. And for the cube root, n is 3, so n is 3, so z 3, so it is cube root means this is 3, and angle is going to be theta plus 2k pi, and n is replaced with 3, and k values which we are going to substitute to find the successive cube roots 0, 1 and 2. Let me go do a little correction. This is also 2. We are calculating here square root. For square root, this n is 2 and this is 2. So these are two formulas for the square root and cube roots. Similarly, if you want to find the fourth root, then we will replace n with 4, and the values of k would be 0, 1, 2 and 3, and so on. Okay, so far we have learned how can we find the square root of a complex number in Cartesian form. So now let's convert our Cartesian form into polar form. The process is simple. The first step is find the length, magnitude of the given complex number. The process is square of the real part and of imaginary part, and then take the square root. So we have 5. 5 is the length or magnitude of this complex number, and then we find its argument. This complex number is in first quadrant, so it means its basic angle is going to be its argument. So basic angle would be tan inverse of imaginary part over real part. This is your basic angle as well as your argument. So tan inverse 4 over 3. Let's see what is the answer in radian mod. So answer is 0.927295 218. So if our intention is just to write the complex number in polar form, we will consider the angle to 3 significant figures. So 5 cos of 0.927 plus iota sine 0.927. This is our modulus argument form, or you can say polar form, and the spiral form or the exponential form would be iota 0.927, or you can say 0.927 iota. So these are the corresponding forms. So now let's find out the square root of a complex number. We know the formula is that if we have a complex number in terms of polar form, let's say r cos of theta iota sine of theta, then its square root would be square root of the argument form, and then we find the argument means angle. The process was theta plus 2k pi divided by n means whatever root you are going to calculate. We are going to calculate square root, so the n is 2, and the values of k we are going to replace are 0 and 1. Okay, now here in this question our complex number is 5, and then the question is cos 0.927 plus iota sine 0.927. So let's focus on the angle and on the length as well. Okay, so for the first square root we will substitute k is equal to 0. So let's substitute k is equal to 0. So the first square root would be z square root of 5 and argument. So now we are going to focus on the argument. So argument is going to be theta, k is 0, so it means 0 over 2. What was our argument? Argument was 0.927. Let's write on the complete value, 927,295,218 divided by 2. So the answer is 0.464. So you can say the first complex number in polar form is square root of 5 cos 0.464 plus iota sine 0.464. This is our first square root in polar form. Similarly, now let's find out the next argument. So the main tricky part is the argument. So let's find out the argument when k is 1. So I'm going to work on the argument first. The argument is going to be theta. So theta is 0.927 295,218 plus 2 k pi. K is 1, so it is 2 pi divided by 2. So this is going to be 0.927 295,218 plus 2 times of pi, whatsoever the answer, divided by 2. So our argument is 3.61. So our next complex number in polar form is square root of 5, then cos 3.61 plus iota sine 3.61. Now we have to take care of one thing, that is what is the value of pi. Pi is 3.142, so this is not inside the range. It is supposed to be within the range of minus pi to pi, so I have to take care of that argument. This is not the right argument, so we have to make a correction of this. So it means I have to rub this at the first place, and then we have to do the calculations. So okay, now let's find out the cube root of a complex number. For that matter, let me take an easy example. Let's say I have a complex number, z is equals to 8. Let's convert this into polar form at the first place. Its length is 8 and the argument of z is 0. We know the standard procedure. What is that? That is, first of all, if we want to find this cube root, if we want to find the cube root of a complex number, it means cube root of the modulus, and for the angle part, that is argument plus 2k pi divided by 3, where the values of k are from 0, 1 2. Okay. Okay, so let's find out. First of all, we are going to find out the first cube root. So for that, I'm going to substitute k is equals to 1. So the major thing is the angle. So let's focus on the angle at the first place. When k is 0, what is going to be the angle? Angle is going to be theta over 3. That is 0 over 3. So it is 0. So the first root argument is, let's say the first root z1 is 0 radians. So when k is equals to 1, it means now the angle is going to be, k is 1, so it is 2 pi over 3 as it is within the range. So argument of the second part is 2 pi over 3, and when k is 2, then let's say angle would be 3 to 3 to, so it is 2 pi. The angle is going to be, when we substitute 2 to the 4, it is going to be 4 pi over 3, as it is not within the range. So I have to do a little adjustment. 4 over 3 minus 2, this is minus 2 over 3. So the argument of this complex number, that is the third one, is going to be minus 2 over 3 pi. Okay, now we have all the complex roots and their lengths. So let's write it down. So the first cube root in polar form. It is going to be the cube root of the, obviously, argument length form, and the first angle is 0. So cos 0, iota sine 0. So the first cube root is simple, straight away. Second cube root, z square 8 cube, so it is cos of 2 pi over 3 plus iota sine 2 pi over 3. If it is required to write the answer in polar form, then this is the answer. If you want to find out in Cartesian form, then obviously we can do that. 2 pi over 3 times square root of 3 is square cube root of 3 it's cube root, it is cube root of 8, and times answer. So it's minus 1 plus now similarly, let's find out the third cube root. That would be z3, it is 8 cube root, argument is 2 minus 2 pi over 3 plus iota sine minus 2 pi over 3. This is in polar form, and we can write the Cartesian form, which is going to be minus 1 and minus plus 2 is going to be minus square root 3 and 8 times cos minus 2 pi over 3. It's minus 1 still. Okay, we have iota over here and iota over here. So these are 3 cube roots using that standard formula. Similarly, we can find the fourth root of the complex number as well. Alright, now let's find out the fourth root of a complex number. For that matter, let's take an example. Minus 8 square root 3 iota. Let's find out its modulus. Length, it is going to be 64, and then taking the square root, we have 16, and its argument, you know how to find the argument, so I'm writing directly. Its argument is minus 2 pi over 3. Now as we are interested in the fourth root, so the formula is going to be z4, so n is 4, we will take the fourth root of the modulus thing, and the angle will be the argument theta plus 2k pi. These things are fixed, divided by whatsoever the root. Here we have fourth root, so n is 4, and the values of k will vary from 0, 1, 2 and 3. Like in square root it was only 0 and 1, and in cube root it was 0, 1, 2. So now let's start. So first of all, for k is equals to 0, what would be the angle? The angle is going to be theta over 4. Theta is minus 2 pi over 4. So 2 pi over 4, 2 pi over 3 into 1 over 4, that is going to be minus pi over 6. This is our argument for the 0, for the first fourth root. So the first fourth root is going to be 16, it is 2 cos minus pi over 6 plus iota sine pi over 6. So now let's solve. This is in polar form. If you want to have it in Cartesian form, just use the calculator and find the value into 2. So the value of x is square root of 3, and then we have sine pi over 6 times 2. It is minus 1. So this is your first fourth root. Now repeat the same process for k equals to 1. Let me change the ink. So k equals to 1. So let's find out the angle at the first place. So it is theta plus 2 pi over 4. And what is theta? It is minus 2 pi over 3. So 2 pi over 3 plus pi. So 2 minus 2 over 3. It is 4 over 3 pi divided by 4. So it is pi over 3. So the argument is pi over 3. So it means now our complex number is going to be, that is the second fourth root would be 2 cos of pi over 3 plus iota sine pi over 3. This is in polar form, and we can find the corresponding value in Cartesian form just using the calculator. Cos pi over 3 times 2, this is 1, plus sine pi over 3, so it is sine pi over 3, whatever the answer, times 2, so it is root 3 iota. So it is root 3 iota. So this is also in iota. Okay, so this is the second root. Similarly, we can find the third, fourth root. Similarly, let me write it down for you. Now you know the basic concept. The process is the same. Let me change the ink color to maybe divided by 4. 4 over 3 minus 2. So argument is minus 2 pi over 3. You know how to find out the argument. So it is minus 2 pi over 3 plus iota sine minus 2 pi over 3. So let's use a calculator. 2 cos minus 2 pi over 3 times 2. It is minus 1. Real part is minus 1, and the imaginary part is square root 3 iota. Let's check it out. It is minus 2 pi over 3 times 2. Yes. So these are the 4 roots of the complex number. In polar form, in Cartesian form as well. You can write all these answers in spiral form. That's not a big deal. Let's say for the last part, I'm writing it down it is 2 over 3 iota. So like you can write rest of the polar forms in exponential form as well. So the main thing is, how can you find out the square root? First of all, you convert it into polar form. You find its angle, its modulus, and then you apply the general formula. If it is cube root, n is 3, square root n is 2. If it is fourth root, n is 4, and the values of k are 1 less than the root. And then after solving it, we have the square root, cube root, and fourth root. Okay, now let's use the calculator. First of all, press mod. Second option is complex. And after that, now let's see how can we convert any complex number into polar form. So let's say 3 plus 4, then this I button, which is in E and G key. Now we want to convert this into polar form. The shift, then this complex options at number 2, then this number 3 option. If we press this, now this equals means 5 is the 5 is the length, and 0.92792955128, this is the argument. So this Cartesian form is easily transformed into polar form, or other way around we can do that. We know that 5 and this angle sign is at this minus key, then 0.927 927 295 295 218. This is the complex number argument and its modulus. Then press shift complex number. When we press 4 key, now this complex number will be converted into Cartesian form. This is how can we convert complex number Cartesian form into polar form, or polar form into Cartesian form. Now let's explore how can we find the square root of this complex number 3 plus 4 iota with the help of calculator. Okay, now first of all, let's see, can we do it directly? Let's put square root, then we write this 3 plus 4 iota. When you press equal, no, it's not possible. Okay, now let's find out the square root using the calculator. For that matter, let's save this complex number 3 plus 4 iota. This ENG key will give us iota. Then shift and then RCL key. This means we are going to store this value in some fixed memory. Which memory? You have options A, B, C, D, E. So I'm going to press A. So this number 3 plus 4 iota is stored in memory A. Okay, now the real part starts over here. Now this square root key, shift this HYP hyphen key. Now we have a modulus key. Now inside this modulus, I'm going to mention my complex number, which is A. Then this right arrow, so that we have outside the square root thing. Then this angle key, which is written in this minus sign, shift, then angle, argument, then 3 brackets, then the argument. To shift complex number menu, number 1 argument of complex number which is being stored in memory A, bracket close, then plus, what we are going to do, plus. Now for the complex square root, first of all we substitute k0. So when k0 means theta plus 0, because k0 means no factor of 2 pi, and then divide by 2, and then last bracket close, so equals to, this is our first square root, which is 2 plus iota. Now in order to find the second square root, we are going to replace k is equals to 1 in this n is equals to 2 square root format. So when we substitute k is equals to 1, so this means theta plus 2 pi. Okay, now let's do that. Okay, now let me solve it again. So shift, not shift, it's the square root, shift hyphen alpha, this key outside the brackets, then this angle sign, 3 brackets, then we have complex menu, argument, complex number, A, bracket close, plus 2 pi this time, because value of k is 1, divided by 2 because it is square root, very close. Now after pressing equal, we will get second square root, minus 2 minus iota. So simple, crazy simple, isn't it? All right, now let's find the fourth root of the complex number. Process is the same. Let's repeat it once more. First of all, mod 2 complex menu. Now let's store the complex number, which is now minus 8, minus 8 square root of 3, and then iota. Not like this, it is outside the square root, iota, still inside, so it is iota. Okay, this is our complex number. Let's save it in our fixed memory a. Okay, now let's find out its fourth root. So this time it would be shift and then the sign. No, it's a square, it's not it's cube root. So let's write 4 over here. Then over here we will write down shift hypotenuse, so it is modulus, and from the memory we have the complex number which we have just stored in the memory. Shift angle sign, 3 brackets, then shift complex menu. From there we pick argument of the freezed complex number and bracket close. Then first of all we substitute k 0, so we have plus 0, and then bracket close, plus 0 plus 0, bracket close, divided by 4, because now this time we have fourth root. So it is yes, the first complex to fourth root is root 3 minus iota. Now let's repeat the resist process again. Now we are going to replace k equals to 1, so we will write over here 2 pi, and then equals, so it is 1 plus square root of 3. Yes, it is 1 plus square root of 3. Now after that we replace k with 0 1 2, so it would be 2 to the 4 pi, so we will write 4 pi over here, 4 pi. So this is our third square root, minus 3 root plus iota. And finally the last one, k equals to 3, so it would be 6 pi, so it is minus 1 minus 1. So we have all the 4 roots of the complex number. So the process is very simple. Whether we are calculating the square root, cube root, or fourth root, first of all we activate the complex menu from mod 2. We feed the complex number in the fixed memory, then we write down the formula, and in that formula we use n4, 3 or 2, whether we are calculating fourth root, cube root, or square root, and the values of k would be substituted 0 1 2 3 0 1 2 3 for fourth root, 0 1 2 for cube root, 0 1 for square root. I hope that this video is useful for you. Now you can calculate easily complex square root, cube root, and fourth roots, and you can easily convert any complex number from Cartesian form to polar form, and from polar form to Cartesian form as well. Now if you explore a little more, you can add the two complex number by feeding them in two fixed memory, let's say a and b. Then you can add those, you can multiply those, you can even divide those complex numbers. So I hope you find this video very useful and beneficial. If Okay, so far we have learned how can we find the square root, cube root, and fourth root of a complex number in polar form. Now let's revisit the De Moivre's theorem. That is, if the power is some integer 2, 3, 4, 5, then what we will do, as the formula is obvious, it is written off of, let's say if we have z equals to some complex number, maybe let's say 2, and the argument is, let's say, pi over 3 plus iota sine pi over 3, and you have to find its square of this complex number. It means square of the magnitude and square of this whole complex number in polar form, power 2. And what this de Moivre's theorem says that whatsoever the angle is, whatsoever the power is, it will be multiplied with the angle. So it means it becomes 4, then cos 2 pi over 3 plus iota sine 2 pi over 3. So that would be the square of this given complex number. Let's take another example. Let's say if we have a complex number p is equals to, let's say 5, angle maybe 2 pi over 3 plus iota sine 2 pi over 3, and you have to find q. P is 2 pi 3, 5q cos 2 pi over 3 iota sine 2 pi over 3 all power 3. So the Morris theorem says that this power will be multiplied with the angle. 5 cube is 125. It becomes cos 2 pi plus iota sine 2 pi. Now after writing the angle, you have to go back and see the range of the argument. We know the range for the argument is always from minus pi to pi. In fact, this is not equal to minus pi to pi. As this angle is not inside the range, so what we will do, we will subtract 2 pi from it if it is greater than pi, or we will add 2 pi in it if it is less than minus pi. As in this case, it is greater than pi, so we will subtract 2 pi from it. So the argument would be 0. So it will be cos of 0 iota sine pi, sine of 0 as well. Let's take another example. Let's say if we have q equals to 3 cos pi over 2 plus iota sine pi over 2, and you have to find cube. Q is to power 3, which means cube of this 3 and cos 3 pi over 2. Angle is multiplied with the given argument using de Moivre's theorem. Again, this angle is greater than pi. So what you will do, you will subtract 2 pi from it. So whatsoever the answer, that would be your argument.